For learning check 9, start with the top coded version of the total cholesterol and Haynes data set. So this is where all total cholesterol is greater than 500 are set at 500. And then open this PDF for question 1. In this PDF, once you've read it, you can return to the first question, which asks you, based on this web page, individuals should begin having their cholesterol measured at what age? So we can go back to here and take a look at what age, and it says here at the top of the first page, everyone age 20 and older. So that includes 20-year-olds, 20 and older. 20 and older should have their cholesterol checked. So once you do that, you would enter 20 in here, and then once the data filter is applied to restrict this sample to that age range, we want to know how many individuals there are. So if you take a look at this, remember we have 8,291 participants in this particular survey. But if we take a look at our ages, so analyze distribution, we can see that we have people that are less than 20 years old. So remember, we want to restrict this to people that are 20 and older. There are a number of ways that you can do this in JUMP. One of them is to apply a local data filter. So under the top red arrow, not this one, but the top one, apply local data filter. And we want to use the age variable. And then we basically can type in 20 here. And it's going to then restrict the minimum age. You can see here at 20. Remember, before it was 6. It has done nothing to the remainder of the data. And this gives us our count of 5,588. 588. So one of the options under the local data filter red drop-down arrow is show subset, because we want the subset of the data. So if I click on that, it's going to show me this 5,588, but just by age. And the reason that it did it just by age here is because I actually have the age column selected in the primary data set. So I can close this. I can go back to the primary data set, press escape, go to rows, row selections, select all rows. So now all my rows are selected, all of my columns are selected, and if I go back to my distribution, I can again ask it to give me the subset. And you'll see now that I have a subset with all of the columns selected. So I have my 5,588 people that are 20 and older. And again, just to verify, analyze distribution on age, and you can see 20 and older only. And so you'd want to make sure to save this data set as your 20 and older data set. So aside from using a local data filter, how can you do this? Well, one of the things you could do would be to go to the tables menu and sort. And I want to sort by age and press OK. You can see I get a different data set here. And you can see that here are all of my youngsters. Here are all my youngsters. So if I continue all the way down to the ages of 20 through 19, so not including 20, I can hold the Shift key and collect all of those, and I can then go rows and I can delete them. And again, I'm left with 5,588, and I can save this. So that's a pretty straightforward way. I could also do tables summary. And I could do a summary by age, press OK, and you can see here that I get a subset where it's giving me a row for each of the ages and then telling me how many people are in that age range. And again, here I can select all of those ages that are less than 20, and you can see because it's tied to the primary data table, it's highlighted all of the rows of people who are less than 20. From here, I can do one of two things. I can go to the rows menu and delete, and that would leave me with a data set that just has the 5,588. The problem with that is we are in the main data table. And if I press delete from here, then I've changed my total primary data set. So I'd have to remember to save as. I don't want to overwrite this primary data set. The other thing that you can do here is go into the rows and exclude. And you'll see when I press exclude that I get these little no signs, or what I call the no smoking signs. That's excluded these rows. So you can see down here, I have 2,703 rows selected and 2,703 rows excluded. If I pull up my calculator, I had 8,291 rows, and I have excluded 2,703 rows. That gives me 5588, what I was looking for. But I can also check that with my distribution. And take my distribution of age, and we can see again that we are 20 and older, and I'm 5,588. And now I just can continue on with this with my excluded data or one of the data tables that I created. So that gets us to the 5,588 people here that have individuals that are older than 20. So we move on to question 2. So we want to use the guidelines on the web page above to create a categorical total cholesterol variable appropriate for use in this contingency table analysis. Remember, our total cholesterol variable right now is continuous. If I go back to jump, I've got my total cholesterol top coded here, and if I do a distribution on my top coded variable, I can see that I've got 5,342 people with cholesterol values of my 5,588. They range from a minimum cholesterol of 69 and of course a top coded at 500. It's a large distribution of data. It's got a large standard deviation, and it may not be of critical importance that somebody's a total cholesterol of 161 and somebody's a total cholesterol of 162. We might simply be interested in looking at the desirable categories. So if we go back to our high blood cholesterol, we can see here in this particular data report that we have total cholesterol values here that are into 3 categories. And so those categories are less than 200, 200 to 239, and 240 and greater. And they are desirable, borderline high, and high. So we need to create a variable that takes our top-coded cholesterol and puts them in these categories for frequency analysis. Remember, a frequency or contingency analysis is 2 categorical variables. Asking here for a brief interpretation of the variable you created using the interpretation guidelines. So how would you interpret a categorical variable? First, we need to create it. There are, again, a couple of ways that you could do this. The cheat way, or the quick way, would be to sort your data by total cholesterol. So let's go ahead and do a sort, and then get our total cholesterol 500 and sort it. And it's going to give us a table, new table, because we're sorted. And I can go over here to my total cholesterols, and you can see I have ones that are missing. And then we start to get into the lower level categories. So I already have a variable here that I've done, which we'll look at in a moment, but to create a new one, simply create, let's do total groups, and it's going to be character, and it's actually going to be ordinal, and I'm going to press OK. And so these we're just going to leave as missing. They are missing, so remember that's just a blank column value, so we don't have to do anything. So I can scroll down here and find my 69. So remember, everything less than 200 is desirable. So I'll just put desire here, and I can copy this, and I could then paste it for everything that's less than 200. But we have 8,291, and this is also really easy to make a mistake. So unless you're dealing with a very small data set, I don't recommend this as being the way to create this variable. So I'm not going to save this. One of the other ways we learned about was recoding variables. So remember, I can select my total cholesterol, I can go to the columns and I can go to recode. I can go to recode and we can do our new values here. But this is also a lot of values. Again, it would be a lot of cutting and pasting to recode this. So I'm going to close this. What you really want to do is create a formula. So let's do that. New column, and I'm going to do total cholesterol groups, character, and I want this to be ordinal. And my column properties, I need to do a formula. And then I need to edit the formula. That's going to bring you the formula box. We need a 3-level if then else statement. So if cholesterol is less than 200, I want the new variable to read desirable. So we're going to go over here to conditional, all the way on the left over here to conditional, and click on the little down arrow and do an if statement. So if, and now I need this little blue box here, total cholesterol, and now I want to go to comparison, is less than 200. So this is my first level. And then I want it to be desirable. Here's the thing with jump. Because we're a character, we need to start it with a quote, but you only need to type one quote. You can see now that 2 quotes have appeared, and all I need to do is type desirable and press enter. I do not need to enter a second quote. Watch what happens if I enter a second quote and press enter. It's going to tell me I've made an error or a parsing error because I've got a quote in between quotes. So we'll discard our changes here and we'll start over. Press quote, type desirable, press enter. No second quote. So I have one level done. Now I need another one because I'm going to need a middle one and then an else one. So I'm going to hit the double insert button all the way up here on the top, this double insert button. Hit it once, hit it twice. Now I need to do my next level, which is 200 to 239. So if I go back to my comparisons over here, I can see that they're allowed to be 200, but I need them less than 240. So I'm going to click this one. I'm going to type 200 here. I'm going to put my total cholesterol there, and then I'm going to type 240 here. Because I know I only have integers for this, I don't have to be worried about 239.9. I only have integers here. And so this is my high, borderline high group. Borderline high. And remember, you just had to type one quote and press enter. And then everybody else. So there's 2 things that you need to be aware of. I know that I have some missing cholesterol variables. If I do an else clause, it may work, but it may also assign those that are high risk from missing because it's everything else. So if it's missing, then it might get high risk. So I'm going to do my double caret again. And remember, if now total cholesterol is greater than or equal to 240, and this is my high risk. Press enter. And now I'm just going to do empty quotes here. So just press quote and enter. And so that means that if they're not within one of those categories, I just want them to be missing. And press OK. And you can see here that I've populated. And I'd already done this before, so it's matching. And I want to press apply. So here's my issue. I want this to be ordinal, right? I want this to be an ordinal categorical variable because there is an order to the desirables, the borderline, and the high risk. If I simply do an analyze distribution, my total cholesterol groups, you can see that my borderline high is coming before my desirable, and that's because of the alphabet. B comes before D in the alphabet. So I need to tell jump that these are in a different order. So I go back to my columns, information. Under column properties, I want to do value ordering. So here's my missings. I want to move that down. Here's my borderline high, and I want to move that down. So now I've got desirable, borderline high, and high risk, and press OK. It doesn't do anything to the data, but it will do something when I press Analyze, Distribution, Y, my total cholesterol groups, and now we can see that we've got our desirable group first, our borderline high in the middle, and our high risk at the top. And you can then report this to answer that second question. Now, you want to make sure that this worked. The quickest way to make sure that that worked is to actually run an ANOVA on it. We're not going to do an analysis, but we can run an ANOVA to check. So I can go to Analyze, Fit Y by X. I can put my new total cholesterol groups in X, and I can put my total cholesterol top-coded in Y, and I can press OK. And then I can ask it for the quantiles. And this way, I can see that I've got 69 to 199 in my desirable group, right? That's less than 200. I have 200 to 239 in my borderline high group, and I've got my 240 and higher into my high risk, and I still have my 246 missing rows and my 2,703 excluded rows. So that worked. That takes you through this question 2. Question 3 says, well, now I just want to report on desirable cholesterol or not desirable. So desirable versus not desirable. So I can do my analysis on the variable that I've created now and get my number for desirable. Or I can create a new variable. And in this case, we can just recode. So columns, recode, and I now only have 3 groups. So now I'm actually going to do this total cholesterol, desirable versus not desirable. And so my desirables stay the same, and these are going to be not desirable. And I can simply copy this and paste it for high risk and press recode. And I can again do a Fit Y by X to make sure that this worked. So my original top-coded total cholesterol groups versus my new. And you can see here that this worked because my desirables are still desirable, and then what were my borderline and high risk are now underneath the not desirable column this direction. So you can see where they fall in. So this also worked. So make sure to save. And that's how you create that indicator variable, and you can do a distribution to get your desirable cholesterol numbers. So analyze distribution, total desirable versus not desirable. And you can see that we have 3,364. So now you would continue on to recode the education variable. You would examine the income variable and recode that according to the code book. Then you're asked to do this learning check 8 table 2, and I apologize for the incorrect name there. It should be learning check 9. And if we take a look at this table, all it wants to know from you is the percent of people in each of these categories with desirable cholesterol. So now that you have the appropriate number of desirable versus not desirable, this is a series of Fit Y by X's. We want to look at gender, race, education, and total family income. You should have recoded all of these. And what you're basically going to do is do a Fit Y by X with my 2 group desirable versus not desirable cholesterol here. Excuse me, that's my outcome, so put that there. And then let's look at gender, and I have race, ethnicity. You would have income and education recoded, and press OK. And from here, you can get the outcome data that you need for this table. So for instance here, we are looking at gender, females and males. So I need an N and a percent here. So gender and female, I have 2,795 total females. That's this number right here, 2,795. That's this number right here, total females. You don't need to put that in the table. I was just demonstrating what it is, but I have 1,691 of them that have desirable cholesterol, and of my 2,975, that's 60.5%. You can put a percent sign here if you desire. And that's because this is a row proportion. Of the females, what percentage of these have desirable cholesterol? So that is this number divided by this number. That's a row percent. 60.5% row percent. And I can do the same thing for males. I have 1,673 of them, and that is 65.69 or 65.7%. Oh, excuse me. Typing error there, 65.7%. And then the p-value comparing gender to desirable cholesterol tells me it's 0.0001. So this p-value is the answer to, is the proportion of those with desirable cholesterol different across gender? It also answers the question of not desirable, because these two numbers add to 100%. These two numbers add to 100%. Comparing the yeses is the same as comparing the nos. So we're comparing our event of interest, which is desirable cholesterol. And our answer is yes. There is a difference in the proportion of women that have desirable cholesterol compared to men. And it turns out in this particular data set that a lower proportion of women have desirable cholesterol compared to males. And then you can go on and complete the table for your ethnicities. So Hispanic, non-Hispanic white, non-Hispanic black, and other, including multiracial. And then you could do your education and your total family income. And that is how you complete these tables. So you can see that we've started to collapse our data preparation, our data summaries, and our testing into a shortened reporting system here in a table. So you can then answer question 7. You can look back over all of your analyses and answer question 8. So we've looked at this cholesterol data set in a number of ways. Go back to the prior learning checks and answer which type, and this is really your personal opinion, which type of statistical analysis did you find easiest to write about and why? So you don't need to restate everything, but just say why you found it to be the easiest. And different statisticians, different analysts have different answers to that question. Do you find proportions easier to write about, or do you find means easier to write about? So just think back on it and think about what you did and give an answer for that.